gonna go ahead and get started here. So welcome to the February first Tuesday. And we have a very special speaker today, Dr. Chris Pulliam. So Chris is recently come back to Cleveland. He's maybe our newest FES Center PI, and is a assistant professor in biomedical engineering. And he did his PhD here with a brilliant scientist. That's me. And you know, that was a while ago now, like 10 years, right? But Chris is back, and he is looking to define a research area, and we're going to hear about that today. So take it away, Chris.
Yeah, thanks, Bob, and good to see everyone. Kind of good to start seeing people in person as well. So as Bob mentioned, I'm really kind of a new old face for many people. And what I thought I'd do today is try to share a few thoughts coming out of the strategic kind of planning meeting that we had a couple weeks ago, sitting there listening, kind of digesting some of the new directions that the FES Center has moved into since I was a trainee here. And kind of had a few thoughts that I'd share, maybe to drive some conversation. So this is not a research presentation. I'm not gonna pepper you with a bunch of data slides. It's really a little bit of background.
I'm gonna intervene here.
Yeah.
That's what we're supposed to do at these meetings, by the way. Not present research as all, talk about what your ideas are, get some critical feedback. That's the idea.
So we'll see. We'll try that. I'll try that today. I'll be a bit of a guinea
Chris
pig.
is still listening to me.
I try. Most of the feedback's pretty good. But the idea was to try and just share a few thoughts on a space that is, I would say, very relevant for the FES Center. It's not something that we maybe have a huge footprint in today, but certainly they have a lot of expertise in the area. So, we'll kind of work our way up to spinal cord stimulation for functional recovery or neurological injury. We'll kind of start with a little bit of history. So most people are probably pretty familiar that spinal cord stimulation is a kind of long-standing commercially available therapy for chronic pain. So 50+ year history, small history lesson, those who know Tom Mortimer, Dr. Mortimer was kind of had one of the key findings in collaboration with a clinician at Western Reserve big school, College of Medicine, when he was at the Case Institute of Technology. And the basic idea is that electrical pulses, electrical current is delivered to the spinal cord through a lead that's placed in the epidural space. So those leads have different designs. Sometimes the leads have cylindrical electrodes. Sometimes they have paddles with planar electrodes. But the basic idea is that different types of electrical pulses, different waveforms, different frequencies are delivered to the spinal cord. And in chronic pain, that's been shown to have a profound effect on pain. So this is a widely, I don't know the commercial numbers, I probably should know some of them, but it's a widely implanted, commercially available technology that more recently, but recently in quotes.
So I will say it's the most commercially successful application of functional electrical stimulation. It's been around a long time and it's used widely, especially
compared to what other applications?
for like stroke pumps, anything else like that, especially in recent years, sort of pumps that put opioids into the spinal cord are not looked upon the same as they once were.
Yeah, so it's I would say maybe come under some scrutiny. If you follow pain treatments, like the payers, like insurance companies, there have been some papers that have kind of critiqued the evidence behind spinal cord stimulation and argue maybe a lot of that critique is not founded, but it is a really, there's a whole industry behind it. The major neuromodulation companies all have spinal cord stimulation platforms, and it's a big driver of their commercial business. But as I mentioned, outside of chronic pain, there's a more recent interest in applying spinal cord stimulation for functional restoration after neurological injury, like spinal cord injury or stroke. So same principle though, same technology platform. You've got epidural electrodes. You may need to do this transcutaneously. You deliver current to the spinal cord, and then it's been demonstrated to be able to facilitate some amount of motor recovery that then enables sitting, standing, walking, hand and arm function. Right? So I put recent in quotes. Maybe it's recent. It's probably, I think the group at Louisville probably did some of their early publications, maybe 15 or so years ago, maybe 20. But that's a little bit of an aside. You go back, and this is why go to the library. I feel like people don't really go to the library all that often, but there's actually a much longer history. Pain was one of the earlier indications for spinal cord injury, but people started trying it back in the 70s. People at that time started trying it for all sorts of neurological indications. So here's a figure from a paper in 1985. It's from an individual with spinal cord injury that has spasticity. So the Q row is the EMG from the quadriceps. The H row, or the H trace, is the EMG from their hamstrings. This A is kind of a measure of the displacement of the knee angle. And what they did was they applied a cutaneous stimulation. So that was known in this individual to trigger spasms. So this on and off arrow at the top is the period during which a cutaneous stimulation was delivered. And you can see it kind of generates this, muscle contraction. So the quads activate, the hamstrings activate a little bit. What they did was they then applied or turned on spinal cord stimulation between these bottom on and off arrows. And you can see that the spasm kind of fades away. And then when they turn stimulation off, at least it looks like the spasm in the hamstrings is on roll. So case study, I think maybe end of one in this paper. But you can see that, there's a much longer history where people have looked at spinal cord stimulation and neurological injury, and even thinking about voluntary movement. So the following year, there's another paper, same first author, that kind of makes this observation about allowed a return of additional voluntary control over some movements of the paralyzed lower extremities. So in my mind, I always think about the Louisville group as kind of really leading, but I think they really led more a renaissance of this work than it was a primary discovery. Since then, a lot of things have happened. They've gone on. That group, a lot of other groups have done a lot of work looking at this modality of neuromodulation and electrical stimulation for functional restoration. They've seen, improvements in things like blood pressure. So on this trace, you've got blood pressure on the x-axis, time on the x-axis, heart rate on the y-axis here, blood pressure on the y-axis here, and something about spinal cord injury, a little bit of background. It's reasonably common that individuals with cervical level spinal cord injuries have hypotension, so their blood pressure tends to be low. And in this case, you're able to stimulate the spinal cord and you see the blood pressure goes, or systolic pressure goes from 85 millimeters of mercury up to 110, 120, which is what we might expect. Okay. In addition to blood pressure, there's things like bladder compliance is another area that maybe is getting a little bit more recent focus. This is a paper from last year showing an increase in bladder storage and also an improved initiation of bladder voiding. Okay, so think about spinal cord injury and all the systems that it affects. This research thread of spinal cord stimulation is kind of starting to look at, okay, how can I improve different elements of that? And then again, I kind of led with this, but also facilitating voluntary movement. So this trace is another illustration where in the gray at the top, so they're all EMG from different lower extremity and trunk muscles. The columns are different participants that were recruited in the study. The gray bars are periods where the participants were cued to try to contract their muscles. And then at the top, this was all done without spinal cord stimulation, and at the bottom it was repeated with epidural spinal cord stimulation. And you can see there's kind of grossly, not in this figure any quantitative analysis, but you can see there's kind of an increase in muscle activity in the bottom versus the top. So again, there's this idea that it can facilitate voluntary movements. Now, I'm not going to pretend to explain the mechanisms, just like I wouldn't try to explain the mechanisms of spinal cord stimulation and pain, but the current understanding, from what I've been able to pick apart, is that investigators think that the spinal cord, what the epidural stimulation does is it serves as an excitatory input to the spinal motor neurons via activation of the sensory afferent. So if you can kind of increase that excitability, you can kind of bias the system so that it's a little bit more responsive to the remaining residual descending input. So think back, I can remember one of Hunter's students, Krista, did some work where she was characterizing volitional EMG below the level of injury, and kind of showed that, more often than you may think, people that are complete spinal cord injury, there are some spare pathways and voluntary EMG. So this is kind of tapping into and enhancing or boosting those spare pathways. Okay, so that was pretty quick. It's a crowded field. So where might the FES Center contribute? Maybe we should collaborate. Maybe there's ways that we can collaborate. So there are a few areas, kind of thinking about, the areas of expertise that I think we have here in Cleveland. A few potential. There's probably many other ways that we could contribute here. One being stimulation patterns, another being kind of hybrid systems, where you could maybe combine SCS and other modalities of FES. Looking at new indications, a lot of the previous literature is focused on spinal cord injury. There's a group at Pittsburgh that's starting to look at strokes. Maybe there's some opportunities to collaborate there. We also have a lot of expertise in deployment of technology. So one of the, I'd say, limitations to broader dissemination of this technology is most of the work that's been published to date has required pairing spinal cord stimulation with really intensive motor rehab. So you can imagine that academic centers and things like that, that's available. You can do it in a research study. Maybe that's a limiter to broader dissemination of that. So are there ways that we could use our expertise in technology dissemination to enable home-based training? Not my area of expertise, but certainly here in Cleveland, neural interface design is a big one, and I'm sure there are many others. So I'll touch briefly on two, and then hopefully we can have some discussion. Stimulation patterns is a gross, really high level interest of mine. As you look at the literature in this space, maybe a terrible cartoon, but what I'm trying to illustrate is that most of the work that's been published in spinal cord injury is kind of in a relatively narrow, so it's on a long scale, stimulation frequency on the x-axis. So most of that work is in a relatively narrow range of frequencies between, say, 2 and 90 hertz, let's say. When you look at the commercial landscape of pain, that's compatible. The longest history of spinal cord stimulation use stimulation frequencies in those ranges. But the last 15, 20, 25 years, you're seeing that range of stimulation frequencies expand. So you go all the way up to kilohertz. Dr. Kilgore has done a lot of that work here in Cleveland, Dr. Badra. You also see things where you're looking at really, really low frequencies. So DC block and some of those concepts have emerged as potential stimulation waveforms. And I just have a hard time imagining that where they selected the stimulation range that they selected when they started this work is actually the ideal or optimum. We could have a lot of other discussion about, well, where would you start and what would you test, but in general, there's probably some opportunity there given how big the contribution and the advances in stim patterns have been.
I'll just add that the frequency range, the original frequency range, like 10 hertz, let's say, that was chosen to prevent muscle fatigue and movement restoration. Okay, the muscles fatigue rapidly if you stimulate them faster than that. Well, this isn't.
It's not.
There's no muscle involved, so there's really no reason it has to be in that range.
Yeah. And again, this is kind of a kind of first principles. When you look at the landscape, you kind of look at other indications for spinal cord stimulation. It's at least something that is worth kind of reflecting on whether there's a principled way to explore that space outside of that, kind of first 100 hertz. Again, just thinking about Cleveland and our local environment, we're experts at neuroprosthetic devices. So, Dr. Knudsen, Dr. Che, later, kind of working with Nathan and Dr. Trago, we've looked at neuroprosthetics for stroke quite a bit. But one of the, I hope this is fair, and I hope I'm not misrepresenting anybody else's work. But it seemed like one of the commonly cited limitations were that the absence of volitional EMG and maybe combined with involuntary contractions were noted as a limitation. So some of this early work in stroke is maybe showing that you can use spinal cord stimulation as a modality that may address some of that involuntary action, which then may make a neuroprosthetic more effective. So maybe there's an opportunity for a hybrid approach there. So again, taking a step back, this is I'd say a somewhat crowded field. There's a lot of really established labs that are doing this sort of work. So the kind of question that, you know, not just me, but I think even kind of across Cleveland, we can maybe mull over, discuss today, is whether or not there may be some opportunities for us to add to what's happening in those spaces and carve out a little bit of the niche around. So with that, I will maybe open it up for some discussion.
What do you have in mind, the kind of upper extremity kinds of
Yeah,
things?
that's a fair question. You know, I think it kind of depends. So for me, the first thing I've been thinking about is kind of like the collaborate versus kind of start from scratch. And the group at Pittsburgh, the group in Pittsburgh, so Marco Capogrosso is kind of starting to look at this. He came from Switzerland, I think, and led a primate group there. They're already starting down the pathway in the upper extremity and stroke. So, you know, I could envision, you know, if there's a collaborative model where, you know, we can kind of contribute to some of the work that they're doing and kind of identify a pathway there. That could make sense. So I think that's really maybe the first critical question is kind of figuring out, you know, indication, and then, you know, is it something where here in our community, we kind of want to start and kind of identify a path of our own, or would we like to kind of approach some other established groups that are working? So hopefully that somewhat addresses your question.
Are you interested in recruiting people, or would you like take a modeling approach for some of these?
Yeah, that's a good question. I'll acknowledge my bias here is to do human subjects research. And I don't say that to dismiss what you can learn computationally. I just don't think we know enough about the mechanisms in this space to actually draw principal conclusions from computational models. So I'll acknowledge my bias is to kind of push towards human subjects research, just given my confidence, I think, in what the conclusions we could draw computationally.
Hey Chris, sorry, I came in late, but I just had a question. It might be a naive question. So when I first heard about Spinal, it makes sense for the lower extremity. So you're very thinking about when the first time I saw Marco's talking about using the lower extremity, I was highly skeptical. You have obviously the so how well works for reproducing?
Yeah.
It seems like it.
Yeah, so that's a fair question. So the model is a little different. So you aren't directly, my understanding, you aren't directly driving action here, right? So you're kind of potentiating the spinal cord so that intact voluntary descending commands are able to be more reflected in the voluntary kind of the distal extremity. So even with the standing and gait studies, it's not like we're directly driving central pattern generators and you know, kind of that concept. It's a little bit different. So we'll see. You know, it'll be interesting to kind of follow what Marco and team do over the next year or so. But I think if you buy that the conceptual framework that you're augmenting kind of the intact descending voluntary commands, it could scale, it could be appropriate for upper extremity movements, but you know, you raise a very point. So if you had
I have a question.
so yeah.
Neurological, what's your take on transcutaneous FES for movement after SCI?
Yeah, that's a great question, Ron. You know, I'm kind of a believer, you know, I think a lot, like it probably is a common mechanism. You know, if you, again, I probably shouldn't use the word mechanism, but if the thought is that you're modulating and kind of increasing the excitability of some of those spinal circuits, I think some of that work is plausible, it's credible. You know, it's not, I'm not quite as close to that personally, but there's a lot of, that's another kind of thing, is the non-invasive approach. You could see that as being, having a lot of advantages over having to get a permanent implant. There may be some questions around the long-term, you know, so if you're able to have a longer term kind of, if you're able to facilitate, you know, plasticity and there's some carryover effect, maybe the transcutaneous approach makes more sense. But if it's more an assistive effect that's observed, then maybe the permanent implant makes more sense. So I think that's a great question.
Can you comment on the recent work at Louisville and other places by peripheral nerve stimulation, and should we all buy stock and onward?
I'm not, so I wouldn't make that bet personally. But I'm excited to see what they're doing. It is a kind of so onward, for maybe for those who don't know, they're a newer entrant into the commercial space where they're developing with a target implantable spinal cord stimulator for spinal cord injury. So usually we struggle with problems of, you know, kind of having an orphan indication and it's hard to get technology. This company is really focused on like bringing a solution forward for that patient population. So that's exciting. I think that's a good thing. We'll see how well the effects scale. Something I didn't maybe call it out, but something you'll see in a lot of the work that's been published so far, it's a lot of case series, not a lot of randomized, not a lot of terribly well-controlled studies. So you have to kind of maintain a little bit of a skeptical eye, which is why I wouldn't bet a lot right now, at least. But it is good to see that group getting some well-needed attention.
You're good. You bet.
I'm here. So I found the title of this talk very intriguing because there was a question mark behind FES opportunity, right? So I'd love to hear from you and Bob and whoever else, sort of what are the decision factors for determining when it's an FES opportunity, FES center opportunity? Like how, like, I mean, this is intriguing, I agree, but how are you going to determine that we're going to put resources behind it and kind of chase this as a region, that this is what we're going to be good at?
Yeah, I mean, I can offer a very junior perspective. Bob, you can certainly add, but I just, you know, one of the reasons I wanted to bring this up today was just to kind of start the conversation, because I think a lot of it just comes down to, you know, bandwidth and do we feel like we have a contribution to make? You know, there's a lot of, you know, really good labs. There's a lot of work happening here. So I think the question just becomes one of, you know, is this something where we feel, you know, collectively, and this is a bigger decision than just me, but do we collectively feel we have a contribution to make here that might advance, you know, kind of the intervention if we consider it that. So that's one of my biggest things is kind of just, you know, I have my thoughts on it. There are people who are have more expertise here than I do. Kind of just starting that conversation, kind of getting their input, getting their feedback on it, and we'll see kind of where it goes. So.
And what would be like really validating on that? Would it be finding some sort of like basic research output that you're looking for? Would it be interest from other, let's say, like stakeholders, like hospital systems, corporate partners? Like what would be the most validating thing?
You know, I'll say I'm here because I don't want to think so much about the big picture, like at macroeconomics. I just like other enthusiastic investigators, you know, so I wouldn't label it basic science research necessarily. I think there's a lot of really cool translational stuff that we could do, but you know, I'm not necessarily at a point where you know, I'd want to not do something because I couldn't see the commercial pathway. I think this is really about just seeing if we can advance the therapy and kind of flush things out with it.
Just add a couple things. So I was on the NIH studies section that reviewed these early proposals from Reggie Edgerton, was the pioneer. And then the woman at Louisville.
Herkimer?
Yeah, Arkham, she worked for Reggie and she moved to Louisville from LA somewhere. And you know, the questions are still like the same. What's the mechanism? Reggie studied that extensively, but he did it like in rats or something. And you know, it clearly has some generalized effect at excitation. But I have to say, for a long time, the study section was skeptical, like it can't be that simple. Like, you know, there's plus and, you know, inhibitory things, excitatory things, you know, multi limb kinds of coordination. But it works to some degree. It does something, you know, it does enhance their ability to walk if they, you know, it requires somewhat of an incomplete injury. Now you can call it a complete clinical injury, but there have to be remaining connections to the brain. That's how it works, right? And somehow you're boosting those up. So, you know, you know, people thought, well, maybe it'll work for lower extremities. So I think you said that. Yeah. For the upper extremity, I don't know. You know, there's been biases against using drug pumps up higher in the spinal cord because of its effect potentially on breathing, for example. So would you do that? You know, you'd have to think for a minute or two. Those are pretty high though. I don't know. I was gonna ask if you had thought about it. I think you said something at the beginning about as a rehab enhancement. You know, not as a I'm going to restore movement, but I'm going to sort of help them teach themselves how to use what they have.
Yeah, so I hadn't, that's not a direction I've put a lot of thought into. There's probably some opportunity there, but one of the things I've been thinking about is what element of the training that is, you know, has been published. There's a lot of like gait training, so kind of like stepping, standing, weight bearing training that's been done by the group at Louisville in particular. Part of me wonders though, like if there was you know, how much of that is the weight bearing? How much of it is kind of just the actual kind of facilitation that you get by trying to contract muscles and other things you could do there? So you know, there's probably some opportunity there. Now, would it result in functional gains? I think that would be the big question mark. Could you really train that way enough to increase function? Maybe you could increase, you know, their voluntary EMG signals to some extent. But then maybe, you know, again, maybe that's where, you know, kind of things where neuroprostheses become, you know, it's like you have better command signals for a neuroprosthetic device that are coming from those voluntary pathways. So
you know, what's their goal? I mean, and where are they now? I mean,
Yeah.
You know, is there a commercial device?
yeah, so that's where Onward comes in. So they are, I forget exactly what they're studying in their clinical trial, but there's a company that has licensed whatever IP is out there from what's the group? EPFL, I think had some
14.
Gregor 14 and some of the IP from I think the group at Louisville and UCLA. So they've kind of taken some of that IP and they're running a clinical trial to try to get a commercial approval, but I forget exactly what the outcomes are in their study. So they're pushing ahead. They just hired or recruited. What is Erica's last name? She was the clinical director at Abbott right before this. I'm blanking on her last name. Yes, Erica Ross. So they just recruited Erica Ross. She's now their vice president of the clinical and regulatory for Onward. So I mean, it's a credible thing. My one critique would just be like, I think they went up the height curve a little fast
And
and
they went up the hype curve really fast.
yeah, so, you know, I think
They
if I were
suffered for it for a while too
Yeah.
badly.
to, yeah. So I would kind of, I would poke at that a little bit, you know, I don't know that that was the right way to do it, but they do seem to be building a commercial pathway forward now. We'll see where they end up.
You know what the goal?
I'm pretty sure it's like, it's, you know, if they can potentiate, you know, standing, stepping, you know, so it's not, you know, restoring the ability to walk like, you know, some of that early hype was. But again, I don't want to go too far because I don't know exactly what their outcomes are in terms of what they're doing.
They,
But
they
it's-
do have a big advantage though. There's a lot known about the technology. I mean, it's been applied
Yeah.
for pain
Yeah.
forever. And increasingly sophisticated. And so, you know, Mike Moffat, who's one of our investigators. He's one of the leading experts in the world about that. So you have a.
Yeah, he and I are supposed to. I was
Yeah,
supposed to talk to
there,
him
maybe.
last
Yeah,
week,
yeah.
But I'll connect with him. Blue or Soren, I forget, I thought I saw.
No, go ahead.
Yeah,
I have a question.
Yeah.
So in conditions where you might have reduced NCV, is there a scenario you could imagine that this could be useful in that just as an efficacy measure?
yeah, I think, I think so. That'd be interesting to think about a little bit more. A lot of what's been done here is kind of very. I think because of some of the original press, it's very focused on kind of like that functional outcome. But I think that has kind of interesting thought, like what are some of the other kind of, let's say, secondary outcome measures that might be relevant and kind of pull the thread there a little bit. I'd have to think about that more. Yeah,
For the home training protocols, what are kind of the major hurdles for getting it out of our research? How would you want to help that? 'Cause
Yeah.
I feel like that's a bunch of.
Yeah. Yeah, that's a great question. That's why I was kind of on the second row there, because it's, I could see, you know, we have expertise there. And I feel like there's a need, but I think, you know, with a high level. And this is where, you know, I don't know if, you know, training to kind of modulate and contract muscles is really all that effective, but a lot of these studies haven't controlled for. You know, they prescribed home exercises, but they usually don't control at all for the amount or extent of exercises done. So even just doing a better control study where you kind of prescribe things and you can kind of monitor compliance to or adherence to that kind of exercise, which I think would be informative in and of itself. You know, you can't write a grant for that, but again, that's one of those spaces where most of what's been published is not really well controlled. They're kind of case series and just bringing a little bit more rigor there might tell us a lot about the role that home training is.
Hi, this is Alam from the internet. I have a question for you. I'm not really very familiar with the spinal cord injury, but I always felt fascinated about how complicated the spinal circuit is. And I was really surprised that when you were doing your presentation mentioning the small amount of frequency band or stimulation band that they use for movement control. And I felt this is a little bit doesn't make sense to me, somebody who's not doesn't understand the whole field that much, because like it sounds to me like there's multiple pathways and it depends where the injury is. If you're talking about these descending pathway, they stop on a different level of the spinal cord. So using the same stimulation based on where the injury in the spinal cord doesn't make sense. And the other thing is like you always need to have the reflexes or the muscle feedback to the movement in order for you to develop the whole movement to have a good movement or quality of movement. So why does the field even like thought about a different stimulation pattern or mechanism based on where the injury is in the spinal cord? And the second question, did anybody even consider to look at stimulating the reflexes, or like what you're talking now about the home training program? If you're asking them to do just flexion and extension, that's good. But if you actually think about the reciprocal inhibition, or thinking about each reflexes, or all these afferent feedback to the spinal cord that could probably improve the outcome, since it's sending back the information to the central nervous system about how the movement is.
Yeah, all great points. There's some in the discussion in some of these publications, it's often referenced that a big piece of the effect of the rehabilitation kind of plan that these participants go through is exactly that. So it's to what role does the afferent feedback when people are going through gait and standing training, what role does that play? I don't know that I've seen a great answer to that question. It's kind of raised as a, kind of point for future research in most of the papers, but no one's really done it systematically. To your point on stimulation patterns, that's one of the things that if it's been tried, it hasn't been published. Most of what's been published uses what I would consider to be some of the legacy spinal cord stimulation for pain parameters. So it's continuous stimulation. Maybe it's cycled. It's kind of a fixed frequency. So there really isn't much that's been published. I don't want to say it hasn't been done, but there's not much that's been published. It's pretty, I'd say, traditional stimulation paradigm from that perspective. If we look at, if we're to try to draw parallels with chronic pain, there's been a lot of work there. So I kind of alluded to that. A lot of people are doing, kind of different flavors, and again, different waveforms kind of tap into different mechanisms. They all seem to have some effect. Some work better than others. So without that mechanistic understanding, it's kind of a tough thing to do in a principled way, which may be a reason not to do this sort of work, right? So I'll acknowledge that, this is not one of those systems that you can jump in and have a very kind of directed exploration, because we just don't have those first principle understandings. So, that may be a reason to stay away from it.
Well, this is why the study section said it can't possibly be that simple. I mean, it's complicated. It's so complicated.
I guess just to clarify, like, is the only difference between the pain spinal cord device and the proposed motor movement one is in the location on where it would be the spinal cord, like ALS versus like more ventral?
Good. Oh yeah, this is a good question. I don't think I put a slide in here on that. So the core technology, I'd say, is like 98% the same. There have been some work that Gregoire 14 has done some work where they're optimizing the design of these paddle electrodes. So they're doing some work where they're trying to optimize that design to maximally target what they think are the kind of anatomical targets for this therapy. But it's basically a paddle lead, which has been used in pain for a long time. So the technology is the same.
It's on the dorsal side of the spinal cord too, right?
Yep.
It's like
Yep.
they're not messing with the other
Yeah,
side.
yeah, they're nothing on the ventral side. There might be some thoughts that like more lateral targets are more kind of appropriate here. So do you try to design an electrode that kind of steers current there or targets the lateral aspects a little bit more effectively? So that's kind of from a technology perspective. To your point on the placement, that's kind of leads are placed in a lot of different places, even commercially with pain, based on where, like, the location of pain. So, thoracic to lumbar, they're placed everywhere in between, and that's kind of the common placement for a lot of these interventions that have been studied, at least in the stepping and standing space. So I don't even think the placement is really that different. They're using I think it's one of the attractive elements of this is technology's ready, basically. The procedures are not new procedures. So it's like the translational pathway, there aren't a lot of like hard barriers. It's really just a question of, does it work? And, does it work well enough to kind of offset the risks? So I think that's why people have been intrigued by it as much as they are.
Cool, thanks.
Yeah.
I guess like to that point, like, but it's been very selective in like pain treatment. Like I'm talking about like the selectivity of what you get from stimulating.
Yeah, that's an interesting question too. Part of it comes down to like the stimulation waveform. And like Dr. Kilgore could probably talk about this much better than I. But you know, there's kind of a couple different, you know, there's gait control and paresthesia based pain relief, which is kind of based on the, you know, you feel it, it's kind of like the whole, you rub it and you feel better. There's other waveforms where you don't feel it at all. You don't feel the stimulation. It's not based on having a kind of acute sensory perception of what it is. Those mechanisms are probably totally different, but they're both effective. You know, selectivity, how selective do you need to be? Again, given what we don't know about the mechanisms, it's kind of hard to say. But again, I don't want to say we don't know anything. I think that there are some really strong hypotheses for what some of the mechanisms are, but not enough that you could, I think, design, you know, a solution from first principles. There's still a lot of open questions. Yeah.
So in the most perfect world where this technology's been flushed out and people can just line up and say, oh, we're going bungee jumping, Pulliam, like for you, where do you see this perfected? Is the end goal so that people have a device that they can have a better quality of life, or is it to be used combinatorially with therapies that are like, because there's studies that are aiming at regeneration, right? So is it so that there's enough stimulation plus regeneration where they don't need to use it forever?
That's a good
So at the end of the day, like, what does this product look like to you? Like, where we've got the, you know, perfect thing, there's nothing else we can modify.
That's a great question. So I have another word, I have a device bias, right? So I'll kind of acknowledge that up front. To me, I think what I see is it's a solution that, you know, a lot of ground to travel, but it's a device-based solution that enables individuals with spinal cord injury and stroke to, you know, go about their lives with, you know, just less impairment from their injury. Your point on the kind of recovery, I think that's an interesting one. It's a little bit outside my kind of direct area of interest or kind of expertise, I guess we'll say. But I think even just having you know, in the short term, while we kind of work on some of the therapeutics, having a device-based solution that, you know, really addresses some of the more severe impairments or neurological injury would be a good place to start. So that's a good question.
Other questions? Anybody online?
Look at the chat.
That's an interesting approach, because like I said before, there's a lot of the sort of the device and surgical techniques and all those things are all worked out for this, which is almost never the case for other applications. But I think what you might want to think about is how to understand the mechanisms.
Mm-hmm.
I mean, I think Mike Moffa would even say that is true for the pain.
Mm-hmm.
We really don't know well enough what we're doing. It works, but it works, you know, half the time and half the people. You know, it's not 100%. It's sort of like it's 50% effective. Well, let me put it this way: it reduces pain by 50% for 50% of the people. So that's not wildly successful. And that's for pain.
Yeah.
You know, you have to have the same kind of thoughts about motor recovery. There are a lot of other side effects. You said side effects, other benefits potentially of this. It's interesting to understand those too.
Yeah.
How they work, blood pressure.
Blood pressure is a big one. You know, there's expertise locally in kind of bladder valve function. You know, Dr. DeBarco and Dr. Kowalski, you know, kind of some of the work that they're doing with cough. So it's not that, you know, we don't have we have a lot of leadership here.
That's actually a pretty good kind of a point to bring up. You know, there's people in Cleveland that do cough. And think of what you do when you cough. It's like half of the muscles in your body are doing something. And they poke one spot and you cough in your spinal cord. So if you wanted to, if you could find areas where movements are coordinated, that could be very helpful. I'm sure you can.
So you might have answered this already, but like I work with DBS a little bit. And there's still some debate on whether the actual mechanism is excitatory or inhibitory, and that kind of depends on like what part of the pathway you're looking at. So is there like a standard mechanism in this, or this is the, because you mentioned like
Yeah.
cough, for example, so would it depend, like would it be excitatory or inhibitory depending on what you're trying to target?
Yeah, so. That's another kind of, like, I'll give you a terrible answer. I think it depends. You know, there are.
I would have said yes.
I think there are elements of this that it very much, it would be kind of an excitatory effect you'd be looking for. There are other elements where, you know, the net effect would be inhibitory, so like spasms, for example. So, you know, patients with spinal cord injury have spasms. You know, at a really high level, you know, you kind of want to reduce excitability to reduce spasms. But the exact same way that they're stimulating that increases excitability also was been shown to reduce spasms. This is where it's like, it's a pretty, it's messy. Maybe I'll leave it at that. So, you know, I think yes, and it kind of is a little bit of both.
Make a comment of what you say, like it's biology, it's complicated, it's complex. Yeah, only 50% of the patients respond. And so actually I was wondering, how common is it in the field to look at responders versus non-responders?
So in pain, that's becoming more common. I think that's a really active area of interest, is trying to understand, use that to maybe guide us towards some of the better mechanistic understanding. In this area of kind of functional recovery, I think that's a newer thread of research where people are starting to look at electrophysiological kind of biomarkers. So can you maybe do TMS and then looked at adult responses, and does that tell you something about patients who are more likely to respond versus not? So that's a slightly, you know, more recent kind of effort, is to kind of try to figure out from the beginning and kind of screen for patients that would benefit from the sort of training and stimulation paradigm.
My understanding is that for the pain things, often they put in wires for patients that have the skin.
Yeah, so
To
pain.
make sure they get benefit before they have the full surgery.
Yeah, so pretty much every pain implant is the first step is what they call a trial. So you get percutaneous leads connected to an external stimulator. You have it for a week, 2 weeks. They test a few different ways of stimulating. If you get enough relief, then an insurance company in the US at least will say, yeah, we'll pay for it. And then that kind of is what gates the permanently implanted device. So pain that's kind of like the procedure workflow for pain devices. You know, this is a new thing. Yeah.
Is this stimulation be reversible? Like, so since you mentioned chronic pain, would this device have to be on all the time?
Yeah, so that's one of the questions I think that's kind of open is, you know, is it an assistive effect that you only observe when stimulation is on? Or is there more of a therapeutic effect where there's some carryover? So that's one of the active areas of research in some of the groups, is kind of studying the time course after you turn stimulation on. Is there any carryover effect? A lot of the earlier work is more focused on the assistive piece of it, but now people are looking at kind of more that therapeutic carryover effect.
A lot of pain too, is chronic especially. Even if the source of the pain goes away,
Yeah,
people still have pain. Their nervous system has told them you have pain, and it could, you know, you could try to find ways to normalize, sort of, the nervous system.
Yeah,
I'm not sure what the analogy would be from here, and I guess they've forgotten how to move, and,
yeah, I mean, it's something else you'll see in pain in this, with this technology is even the simple concept of duty cycling. So, you can turn the stimulation on for a period and turn it off for really long periods, and then patients still experience pain relief. So there's some other, again, another mechanism that, it's not quite as simple as the gate. I mean, gate control theory, good first principles, but it's spinal cord stimulation is a lot more complicated than that.
What's the approximate time scale of that? How long can you have it off without?
Yeah, so I think Mike would probably know this better than I do. But I mean, it can be probably a 1 to 3, 1 to 5 ratio. The on-offs, like the on period, I can't remember exactly, but I mean, it's, people were looking at the longevity of a primary cell device was say 5 years. Just a simple duty cycle approach might, be able to triple or, quadruple that longevity without affecting pain significantly. So Abbott, maybe Boston's doing some of that work too, Medtronic, but they're doing some of that work. So yeah, there's something else that's at play there. And even stimulation turning on, it's not, there are some waveforms you don't get pain relief immediately. It's something that kind of develops over a period of days. So maybe 24, 48 hours before a patient reports feeling relief from their pain. So again, that's another one of those mechanisms that we don't quite understand yet.
and really hard to experiment.
Yeah.
I mean, that's true of a lot of, even some of the BBS things, like for psychological conditions, it doesn't work for a long time. If you get it wrong, you'll never know, right? You can't twiddle it.
Dystonia, even in the movement disorder space, dystonia is like that. So you don't get the immediate kind of visual feedback like you do in Parkinson's. So that's another kind of example.
With biomarkers.
Yeah, I mean, there's whole NIH.
Give you some, what might happen.
Yeah, I think that's in part why NIH is like, there's a lot of funding opportunities that specifically are calling out like the need for biomarkers. And I think this is at least part of the reason why.
Other questions, comments?
Yeah.
Are you trying to like practice this for like a research application or for a teaching application? Like a little unclear about the context of this
You mean
discussion.
like the series?
Well, no, like this, like, because you said you were thinking about, you wanted this to be like a teaching, it was based on the teaching discussion. A lot of the students.
Oh,
were
no. Strategic discussion. So.
Strategic,
yeah, there
oh,
was a-
I misheard.
Yes, well, it's probably me mumbling, but no, there was a few of the FES Center PIs got together 2 weeks ago, probably. A week ago. So for me, it was kind of just a good chance to just absorb information and what's everybody working on. And this was kind of one of those ideas that kind of been sitting in the back of my head and seemed like it might fit in somewhere, so it's a good opportunity just to bring it up and see what
So
people want.
this something more like add to your research
Yeah,
vision?
yeah, that's more, it's kind of, if there's an interest, amongst other investigators, is there something there that we kind of develop together and kind of figure out if there's a way to maybe, may not be a grant proposal to start, but I doubt this is something you can jump into about, some preliminary data, but I think it's something we have to be thoughtful about and kind of really, you've used the term a lot recently, like incubate, so this would be one of those things that would need some incubation and, a lot of critical thought to put into it to figure out where to go. Yeah.
So are you thinking you're gonna start down more of a functional restoration path or?
Yeah, so for me, probably functional restoration, I'd be more interested in that. I have some other, kind of technical skills that I think I could bring to bear there, so that would be more interesting.
And we veered down the pain route because it's sort of a precursor for a lot of this,
I mean, I think there is a aspect to it along with functional restoration. There's gonna be
Yeah, I agree with you, definitely. All right.
Okay.
Thank
Thanks,
you.
Chris.
Yeah, thank you.
This is, while I appreciate all the students and the start showing up, I just want to point out that you all have a really, really easy. Back when we were students,
Oh, no.
we had to go all the way to extra. Go to lectures. Let me get my body. You guys have so many.
And on that note, if you guys aren't getting the invitations, if you could send me an email, just to make sure we have you on the list, you'll get all these invitations and notices for our seminars.
Cheers to that. Yes.
Cheers. Yeah.
We are in a big strategic planning sort of mode, so
Awesome.
I hope we have a lot of these kinds of early discussion.
There are still seminars I've not tried. But they are.
Yeah, you're very welcome. Yes. Yes.